नमस्कार बच्चों, मेरा नाम धन्या और आज हम लोग ग्रेड 11 केमिस्ट्री का 4th लेसन केमिकल बॉन्डिंग, इस लेसन का पास पेपर नीट एंड जेईई क्वेश्चंस, कुछ क्वेश्चंस करने वाले हैं. ओके, सो we will be doing practicing some past paper questions of JEE and NEET. So these are some recent past paper questions. Okay, so coming to the first question, you can see the first and the second question are there on your screen. So coming to the first question, okay, there are two columns given, list 1 and list 2, and they have asked you to match the shape and the hybridization of the molecules. Okay, now we already learned some of the shapes of some molecules during the lesson in one of the videos. Okay, so first one is XeO3. Okay, let's quickly check the hybridization and the number of lone pairs. So we have the formula Z is equal to half of number of electrons in the valence shell of the central atom, which is 8, which is Xe. Xe is from 8th group. We don't have any positive or negative charge, and we don't have a monovalent atom. So the hybridization is 4. Okay, so 4 means it is sp3 hybridization. And number of lone pairs, Z is equal to bond pair plus lone pair. We have been doing this formula a lot of times. So 4 is equal to bond pair. How many bonds are there? 3 bonds are there plus lone pair. So there is 1 lone pair for XeO3. So I have, just moving the screen a bit. Okay, so I have Xe. There is 1 lone pair and 3 bonds with oxygen. So this is pyramidal shape. Okay, so this is sp3 hybridization and this is pyramidal shape. Okay, next is XeF2. So half of 8 plus there's no positive and negative charge, but there are 2 monovalent atoms. So 5. So 5 means it is sp3d. Yes, sp3d. And checking the number of lone pairs. So 5 is equal to how many bonds are there? 2 plus lone pair. Lone pair is equal to 5 minus 2 is 3. Okay, so there are 3 lone pairs. So we keep them as far away as possible, the lone pairs, and fluorine. Okay, now usually the shape over here, when we determine the shape, we ignore the lone pairs. So when we ignore the lone pairs, what shape it is? It is linear shape. Okay, so that we discussed in the video itself. Now the third one is XeOF4. So I have XeOF4. So determining Z, half of number of electrons in the outermost shell for xenon, plus there's no positive or negative charge, but 4 monovalent atom. 8 plus 4, 12. 12 by 2 is 6. So it is sp3d2. Now coming to the lone pair of electrons, Z is 6. Bonds, how many bonds are there? 4 plus 1. 5 bonds are being formed plus 1. How many lone pair is there? Lone pair is equal to 1. Right. Coming to the shape Xe, it has 1 lone pair. And there are 4 fluorine bonds with fluorine. There's 1 oxygen. And the lone pair. Right. Now, while determining the shape, I have to ignore the lone pair. And this is what? Square pyramidal. Okay. Then the next one is, I have one more, which is XEF6. So XEF6. So Z is equal to half of 8 plus, there's no positive or negative charge, but 6 monovalent atom, 7. So that is sp3 d3. And this is actually this octahedral shape, but let's check the lone pairs. So 7 is equal to how many bonds are being formed? 6 bonds are formed plus lone pair. So lone pair is there. That will make it, it is octahedral. Fluorine, 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 fluorine. It has an octahedral shape, but because of this lone pair, it is distorted octahedral. Okay, so seeing all these, which option is correct for us? Our C option is correct, where XCO2 is pyramidal, sp3 hybridization if you check. B is 1, that is linear shape, yes. C is 4th one, which is sp3 d2. And the last one is D is the 3rd one, distorted octahedral. Okay, square pyramidal, the previous one, and XEF6 is distorted octahedral. So we have the answer, 3rd one. Okay, I hope it is clear. So usually whenever this type of a question is given, first find out Z, then the lone pair, and try to recollect the shape. Okay. When you are determining the shape, you have to ignore the lone pair of electrons. Okay. So coming to the second one. The hybridization and the lone pair will give an idea of the shape. Okay, so if you just ignore the lone pair, it will give you an idea. So you don't, even if you cannot recollect the shape, at least the lone pair, with that lone pair and all, no, you will get a rough idea of the shape. Okay, so coming to the second one, there are few statements given. You have to tell me which of them, you have to tell which of them is correct. Okay, so first one is the dipole moment. We know that water is highly polar, right? Water is highly polar. There is a lone pair of electrons. Sorry, the dipoles we drew from less electronegative to more electronegative, less electronegative to more electronegative, and to the lone pair, right? So water is highly polar, right? Now, again, ammonia is also polar, but water is more polar than ammonia because oxygen is more electronegative than nitrogen, and ammonia is more polar than CHCl3. Yes, so this statement, A statement, is correct. Okay. CHCl3 is polar, but the electronegativity difference is very less. So the electronegativity is less for chlorine. That's why it is least polar among the three. So A statement is correct. Yes. Now coming to the second one. In the B statement, XEF4 here. Quickly find out Z. Z is equal to half of 8 electrons in the outermost shell, 4 monovalent, no negative or positive charge. So 6. And 6 is equal to, how many bond pairs are there? 4 bond pairs. Lone pair is equal to 2. There are 2 lone pairs. Now coming to XeO3, Z is equal to half of 8. There's no negative or positive charge. So 4. So 4 is equal to how many bonds are there? 4, 3 plus lone pair. So lone pair is equal to 1. Okay. So first two is correct. The XeF4 is greater than XeO3 in terms of lone pair, but we have to check the third one, XeF2. Half of 8 plus 2 monovalent atom, that is 5. So 5 is equal to 2 plus lone pair. So lone pair is equal to 3. So this 2 is correct, but this is wrong. So our B statement is wrong. Right. Now coming to the third one. So this statement is wrong for us. So I'm just rubbing this. You could see how I solved the number of lone pair. So we found out that B statement is wrong. Now coming to the C statement. Let's check if it is correct. Bond length. Bond length of OH. Now, O is highly electronegative. Now, if the electronegativity is more, now OH bond length. Now, oxygen is a very small atom, and the electronegativity difference between oxygen and hydrogen is more. So definitely OH bond length will be lesser. Okay, so it will not be, this is the statement that is given. Okay, so this is wrong because the bond length of NO will be greater than CH, will be greater than OH. OH, because the small size of oxygen and greater electronegativity difference makes the bond length less. Okay, so this statement is also wrong. Okay, now coming to the D statement. So this is wrong statement. So bond enthalpy, okay, or the bond order. Here, N has a triple bond, so more energy is needed. So bond enthalpy of N2 is, N triple bond N. Oxygen has a double bond. So nitrogen, bond order or bond enthalpy, energy needed to break the bond. Because it's a triple bond, it is greater than oxygen, which is greater than hydrogen. Hydrogen, the bond order is 1. So for hydrogen, least energy is needed. So D statement is also true. So what is our correct answer? A and D, and that corresponds to C. I hope it is clear. Okay. Now, coming to the third question, if you see the screen, which of the following molecule has non-zero dipole moment value? Non-zero. That means they have some dipole. Okay. If we see carbon tetrachloride, the first one, we learned this when we were doing the lesson on dipole moment. So here they have the dipoles from more electronegative to, sorry. The third question is, which of the following molecule has non-zero dipole moment? Okay, so that means they have some amount of dipole. Okay, coming to the first option A, I have carbon tetrachloride, tetrahedral geometry. Okay, so I draw the dipole from less electronegative to more electronegative. Okay, here they are cancelling. All the dipoles are cancelling, right? You can see all are cancelling, so it has 0. Okay, so this is not our option. B, hydrogen iodide. So here from less electronegative to more electronegative. So there is nothing to cancel. So it has a dipole. Okay. So that means this is not 0. It has a, so dipole here it is 0. Here it is not 0. Mu is dipole. Okay. Dipole moment. So this is our answer, but let's check for carbon dioxide also. Carbon dioxide from less electronegative to more electronegative, less electronegative to more. So this is also 0. So this is also not our option. This is not our option. The last one is D. It is BF3. So BF3. So this is the shape. So I'll draw the dipoles. This is from less electronegative to more electronegative, less electronegative to more, less electronegative to more. So you can see they are in opposite directions. So they cancel each other. So mu is equal to 0. So our only option is B. Our answer is B. So B is our answer for this question. Okay, so we got the answer for the third one. Now, coming to the next one, the fourth one. The fourth one, arrange the following compounds in increasing order of solubility in chloroform. Okay, now, you know chloroform, CHCl3. Chloroform is the solvent here, CHCl3. Okay, here I have, this is the dipoles I'm drawing. And here the dipoles are not cancelling each other. So that means Cl3 is slightly polar. Not very polar because it's an organic molecule, but it is very slightly polar. Okay. So that means like solvent dissolves in like substances dissolve. So those substances that are highly polar will not dissolve much. Yes. So this is slightly polar, very, very less polarity is there for this organic molecule, chloroform. Okay. Now, if we talk about NaCl, NaCl is high polarity. It is highly polar because there is polarity created in this positive of positive and negative charge on this metal and the non-metal. So it is highly polar. So definitely, if it's highly polar, there are chances that it will be less soluble in this slightly polar substance. Right. So solubility will be least here for sodium chloride. Okay. Now coming to the next substance, which is CH3OH. Okay. Now in CH3OH, it is highly polar. Also, there's an alcohol group. Because of this alcohol group, they also form, they are polar as well as there is hydrogen bonding. Okay, so that means in order to be polar, these hydrogen bonds have to break first in order to be soluble in chloroform. So chances are there that they will also be less soluble. But it will be more soluble than NaCl. Okay, because it is highly polar and this is just polar. Then the next one is CH3CN. This will also be slightly polar because of the electronegativity of nitrogen, or because of electronegativity difference between carbon and nitrogen. So it will be polar, but it will be more polar than CH3OH group. Okay, the last one is cyclohexane, which is non-polar because it's also an organic molecule. So cyclohexane will be most soluble and sodium chloride will be least soluble. Okay, because sodium chloride is highly polar. Okay, so I repeat once again, chloroform is an organic substance, so it is very, very, very less polar, very less polar. So that means like substance dissolve in like substance. So if it is very, very less polar substances or organic substances will be more soluble, right? Now, sodium chloride is highly polar, okay? And therefore, the solubility will be very, very less. Okay, then the next one will be the next soluble substance, the next less soluble substance will be the alcohol, because alcohol is polar as well as it will form hydrogen bonding. So therefore, this hydrogen bonding has to break first in order to be soluble. So therefore, it will be next. Okay, it will also be less soluble but more soluble than NaCl. Okay, the next one will be CH3CN. It will be a polar because of the electronegativity difference between carbon and nitrogen. Okay, but it will be more soluble than CH3OH. Then the most soluble will be cyclohexane, because it is non-polar. Okay, and this is cyclohexane. The electronegativity difference between carbon and hydrogen is very less, so it is non-polar. It will be highly soluble in chloroform. Okay, so our answer is sodium chloride is, yeah, it is C. C is our answer. Sodium chloride is least soluble. The next soluble is alcohol. The next soluble is CH3CN. The most soluble is cyclohexane. Okay, students, now coming to the fifth question. In the fifth one, there are two statements and you have to tell which is correct or if both of them are correct or not. The first statement is the boiling point of the hydrides of group 16. Follow the order. So this is the order they have given in the first statement one. This is statement one. H2O is greater than tellurium, hydride of tellurium. These are the hydrides of group 16 if you see. Selenium and sulfur. Now let's check whether it is correct or not. So this is group 16. So sulfur, selenium, tellurium, oxygen. Now as you're coming down, what is happening to the molecular weight? So molecular weight is increasing. So van der Waals force also increases. So boiling point increases. So as you're coming down, so sulfur is, so I'll just write in the order as it is written in the question. So tellurium Hydride of tellurium has a higher boiling point than hydride of selenium, which has higher boiling point than sulfur, but the highest is oxygen, that is water, because there is additional hydrogen bonding in water. So this statement is true. Now let's check the second one. The second statement, on the basis of this, the water is expected to have a lower boiling point, but due to the presence of hydrogen bonding, water has a higher boiling point. So statement 2 is also correct. That's the reason we gave. So this we have done in the video as also, right? So both statement A, 1 and 2 are true. So what is our answer? Fifth one is A. Both statement A and B is correct. So they have given the reason for statement 1. Okay. So moving on further, coming to the sixth one. Sixth one is about the intramolecular hydrogen bonding is present in. So we discussed this also. So this is our phenol. And with respect to OH, nitrogen is in the ortho position. And there is chances of intramolecular hydrogen bonding in orthonitrophenol. There can be hydrogen bond between hydrogen and oxygen, right? So we had discussed this when we were doing the lesson on hydrogen bonding, okay? So over here, intramolecular hydrogen bonding means within the molecule. So this is happening within the molecule. But in B is meta position. The nitro is in the meta position. This is not possible because the nitro group is far away, so not possible. In C, it is in the ortho position. This is the ortho position. This is still not possible, so far away, so not possible. Now, in HF, there is hydrogen bonding, but with another molecule. So this is not intramolecular. So this is intermolecular. Our question is intramolecular. So what is our answer? Our answer is A is our answer. Okay. Now students, coming to the seventh question. Among the following, the total number of species not having 8 electrons in around the central atom. Okay. So you have to tell who do not have 8 electrons around the central atom. So this is ammonia having a lone pair of electrons. We drew ammonia so many times. So 1, 2, 3, 4, 5, 6, 7, 8 with a lone pair of electrons. So they have 8 electrons. Okay. Now coming to AlCl3, this is aluminium with the 3 chlorine atoms. Okay. So 1, 2, 3, 4, 5, 6. 3 electrons of aluminium, 3 valence electrons of aluminium, and 3 electrons of chlorine. So 6 electrons. So this is one species that don't have 8 electrons around the central atom. Next one is BeCl2. It has a linear shape. So 1, 2, 3, 4. This is also having an incomplete octet. Then I have CCl4. So this is another one. So Cl, 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 Cl. So 1, 2, 3, 4, 5, 6, 7, 8. So this has 8 electrons. So complete octet. Okay. Then PCl5, P, Cl5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this has 10 electrons. But our question is not having 8 electrons around the central atom. So I have aluminum chloride, I have BeCl2 and also PCl5. So I have 3 is my answer because here it's not perfectly 8, it's more than 8. Okay, so 3 is my answer here. Now coming to the next one. Coming to the next question. Question number 8. Okay, the correct order of energies of molecules, molecular orbital, the correct order of energies of molecular orbital of nitrogen. Nitrogen means 14 electrons. So we need to follow the filling of molecular orbital of species having 14 or less than 14. So this is 14. So we will follow the same order of 14 electron, where we have sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. This makes 8 electrons, 2 to 4, 5, 6, 7, 8. Then I have pi 2px is equal to pi 2py, 8, 9, 10, 11, 12. Then I have sigma 2pz, 13, 14. So this is the order we follow for species having 14 or less than 14 electron. So this has perfectly 14 electrons. So we follow this. And one that matches with this is D, right? Yes. So D, so until here, the electrons are filled until here because it makes 14 electrons. So this is our order. Okay, so D is our answer. Now coming to the 9th question. The 9th question, intermolecular forces are the forces of attraction and repulsion. Forces of attraction and repulsion between interacting particles that will include, okay. Now here we have dipole-dipole forces that are between molecules, okay. Dipole-induced dipole forces also between molecules. Hydrogen bonding also between molecules. Dispersion forces also between molecules. But covalent bond is between atoms. Between atoms. Okay. Sharing of electrons between atoms. So what is the answer? Our answer is A, B, C, and E are correct. So our B option is correct. So they have asked for interacting particles. Okay. So between the molecules. But covalent bond and ionic bond is between the atoms. So B answer is correct. Now coming to the 10th one. Here they have asked to match the shape of a molecule with the shape of molecules. Okay. So the first one is ammonia. Ammonia has a lone pair of electrons with trigonal pyramidal. So trigonal pyramidal. Then I have ClF3 with the lone pair at the equatorial position, and if we ignore the lone pair, it is T-shape. Okay, so this is T-shape. The lone pair is here, but we ignore the lone pair while talking about the shape. Okay. Then I have PCl5, Cl, Cl, Cl. This is trigonal bipyramidal. Okay. And the last one is BF5. BF5. You know how to do the how to find out the lone pairs, etc., right? So we have done in the previous questions also. So I'm just doing directly the answer. So boron, it has one lone pair of electrons. So fluorine, 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 it is square. So if we ignore the lone pair here, we do ignore the lone pair when we are talking about the shape. So what I would do is I would draw the fluorine here. So see, it has a square pyramidal shape. Square pyramidal shape. There is one lone pair that is placed at this side, and we do not check the lone pair, or we ignore the lone pair when we are talking about the shape. Okay. So here, this is the shape of BF5. Okay. So for knowing the lone pair, we have the formula Z. Z is, for example, we have done this finding the hybridization and the lone pair. I'm just giving an example, okay, in case you're just looking at this question. Z is equal to half of if suppose I'm talking about ClF3. Okay, half of number of valence electron in the outermost shell of central atom, that is chlorine, is 7. There are no positive or negative charge. If it was negative, we have to add. If it was positive, we have to subtract, but there is no such thing here. Plus number of monovalent atom, that is fluorine is a monovalent atom, 3 of them. So half by 10, which is equal to 5. So Z is equal to bond pair plus lone pair. So 5 is equal to how many bonds are formed? 3 bonds. So how many lone pairs are there? Lone pair is equal to 5 minus 3 is equal to 2. So those are the two lone pairs I have drawn. Okay. Similarly, you can find Z value and the number of lone pair, which I have done in the previous question. Okay, in the same video. So which option for, okay, students, coming to 11th one, you have been given 4 pairs of molecules. You have to tell which of them have square pyramidal geometry. Okay. Now, coming to the first pair, which is BRF5 and PCl5. Okay. Now, coming to Z, Z value is half. Number of valence electron on the central atom, 7. No positive or negative charge, but there are 5 electrons or 5 monovalent atom. So 12 by 2, which is 6. And PCl5, Z value is half of 5 plus number of monovalent atom. So Z is equal to 5. Right. Now coming to lone pair, 6 is equal to 5 bonds are formed plus lone pair is equal to 1. Here the lone pair is 5 bonds are formed. So lone pair, so we are using this formula Z is equal to lone pair plus bond pair. Okay, so lone pair is equal to 0 over here. Okay, so PCl5 has a trigonal bipyramidal shape. It's not square pyramidal. Okay, and This BRF5 has a square pyramidal shape. Okay, so there is one lone pair, so BR lone pair. So as we are doing, it is a revision for us for the shapes also. So we ignore, for the shapes, we ignore the lone pair. So this is our square, and this is our pyramidal shape. But in this case, both of them don't have square pyramidal. Only one of them have square pyramidal. So our option 1 is wrong. Okay. Now let's move to the second option. Let's move to our second option, which is SBF5 and PCL5. PCL5, we just checked. It doesn't have the square pyramidal shape. We just saw PCL5 doesn't have the square pyramidal. It has the trigonal bipyramidal. But let's check for antimony. But even if antimony does have, the answer will be wrong because both of them have to have the square pyramidal shape. But let's check. Z is equal to half of antimony is from group 5. So 5 electron in the outermost shell and 5 monovalent atom. So Z value is 5. The lone pair is 0. So it has a shape of same like PCL5, trigonal bipyramidal. Okay, so our option is wrong. Next comes the third one. Third one is wrong because third option is also wrong for us because SBF5, we just checked, it doesn't have a square pyramidal shape. So this option is wrong. Now coming to the last option, fourth one, BRF5 and XEOF4. Okay, for our option to be correct, both of them should have a square pyramidal shape. If one has, the other one doesn't have, our option doesn't go right. Okay, so let's check the Z value. Z value is half, 7 plus 5 monovalent atom, that Z is equal to 6. And 6 is equal to, there are 5 bond pairs plus lone pair is equal to 1. This option usually comes out to be correct for square pyramidal. But let's check for this also. Half of 8 plus 4 monovalent. So Z is equal to 6. Lone pair is equal to 6 minus 5 bond pairs. Lone pair is equal to 1. So here, bromine has 1 lone pair. Fluorine, 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 fluorine. If we ignore the lone pair, this is square and this is pyramid. Okay, so we have to ignore the lone pair for this. Here also it is coming out to be similar to this same thing. So here Xe, fluorine, 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 fluorine. I place the lone pair down here and this is oxygen. So here also you can see this is square and this is, all these shapes we have discussed when we were discussing the valence share electron pair repulsion theory. Okay, there is a video on all the shapes and geometry, etc. So you can watch out that video. So when we are discussing the shape, we ignore the lone pair. So our option, which option is correct? Fourth one, because here in the fourth one, we have both the molecules having the square pyramidal shape. Okay. Coming to the next question. Twelfth one. Okay. In the 12th question, which of the following statement is true with respect to water, ammonia, and CH4, methane? Okay, A is, let's check if A statement is correct or not. The central atom of all the molecules are sp3 hybridized. Okay, we have done this so many times. Z is equal to half of oxygen is the central atom here. 6 plus 2 monovalent atom, that is 4. 4 means it is sp3 hybridized. This is Z is equal to half of nitrogen has 5 plus 3 monovalent atom. So Z value is 4. So it is also sp3 hybridized. Z value is half. Carbon is 4 plus 4 monovalent atoms. Z value is 4. That is sp3 hybridized. So A statement is correct. Let's check the B statement. Okay. So all of them, they are sp3 hybridized. So that's correct. We have done this in the video also. We found out the hybridization also. Now coming to the B statement. The B statement says that the HO, H, HNH, and HCH angles are in the order 104.5, 107.5, 109.28 or 5. In some books, they say 28. So this statement is also correct. Okay, we learned about these, why there are changes in the angle. Okay, all of them have sp3, but the different angles because of lone pair, bond pair repulsion, etc. Okay, coming to the third statement, the increasing order of the dipole moment is CH4 is less than ammonia, is less than water. So we have carbon hydrogen dipoles. We have ammonia. Ammonia has some dipole, and this is water. Okay, obviously in methane it is less because the difference in electronegativity is very less between carbon and hydrogen. It is less than that of ammonia, and nitrogen is highly electronegative. So the difference in electronegativity of nitrogen and hydrogen is there. So that's why it is ammonia is more polar than CH4, and ammonia is less polar than water. Water is highly polar because of the small size of oxygen and more electronegativity of oxygen. Okay, so this statement is also true. Now, coming to the next one. So this C statement is also true. ABC is true. Now I have the next statement, the D statement. The D statement says that both water and ammonia are Lewis acid. They are Lewis acid. This is what the statement says. And methane is a Lewis base. Now over here, ammonia and water, the oxygen has 2 lone pairs and nitrogen has 1 lone pair. Now, they are not Lewis acid, but in fact, they are Lewis base. Lewis base means those who can donate lone pair. Now, water and ammonia are in a position to donate the lone pair. So they are not Lewis acid. In fact, they are Lewis base. So D statement is also wrong. Okay. Now coming to the E statement. E statement, a solution of ammonia and water are, ammonia in water is basic. Ammonia in water is basic. In this solution, ammonia and water act as Lowry-Bronsted acid. In fact, here ammonia acts as a Lowry-Bronsted base because later on in grade 11 you will learn that ammonia accepts a proton from water. Ammonia will accept a proton. So Bronsted-Lowry concept says that a base is someone who will accept a proton. So ammonia will accept a proton to become ammonium ion. So that is why it is not an Bronsted-Lowry acid, but it's a base. Okay, so this statement is also wrong. So we have A, B, C, that is, sorry, not the fourth option. Our A, B, C is the first option. First option is correct. Okay, so don't worry about the Bronsted-Lowry concept and all. You will be learning all those. Okay, for now, I just found the question. I thought I should share it. That's why. Okay. Now, coming to the next one. The next question number 13. In question number 13, which of the following linear combination of atomic orbitals will lead to the formation of molecular orbitals in a homonuclear diatomic molecule? Now, they have given the condition internuclear axis is taken as the z-axis. So the internuclear axis is the z-axis. So internuclear axis means the axis around which the overlap takes place. So which is that axis? That's the z-axis. Okay, so let's check the option A. A is 2pz. So this is the z-axis. Usually I take this as z-axis. So it's that's what the statement also says. The internuclear axis is the z-axis. So if this is the z-axis, okay, here you can take it as y-axis or x-axis anyway, perpendicular one. Okay, so this is the dumbbell shape. Okay, so 2pz, and if this is the z-axis, the internuclear axis, then we draw the 2px this way. This is the x-axis, 2px. So this type of overlapping is not possible. Okay, so no molecular orbitals. So no molecular orbital possible. So here the necessary condition is the internuclear axis should be z-axis. So this is the internuclear axis. This you should take it as z-axis. Okay, so this is to avoid confusion and to allow uniformity. Now, in the B1, sorry, it's not A, B, C, right? It's, yeah, A, B, yeah. In the B, it is 2S. 2S has a spherical shape, and still we consider this as z-axis and this is x-axis, and also 2px. So this is the z-axis, so this is 2s, so this is 2px. So this is also not possible, so no molecular orbitals formed. Okay, now C is 3dxy. So 3dxy, this is y and this is x, sorry. X, yes, and 3dxy. So here the double dumbbell is something like this in 3D XY. And in 3D x square minus y square, it is, this is x and this is y. It is along the axis like this. Okay, so double dumbbell shape look like this. So this also not possible. No molecular orbitals formed. Okay, now coming to the fourth one. So D. In D, we have 2s. So 2s is, S is along, is the spherical shape, that is Z, and this is X. Okay, and two PZ. So this is the Z and this is X. So this is possible. 2PZ. This is possible. Okay, so here molecular orbitals are formed. The last one, E, is two PZ. This is X and this is Z. 2PZ and 3D x square minus y square. So this is x square minus y square, which is not possible. No molecular orbital formed. So our answer is D only. Second option is our answer, that is D only. Okay, so this is how we solve it. Okay. Coming to the 14th question. Okay, in the 14th question, you have to tell me the number of, you have to tell the number of S and sp3 hybridized carbon atom. Okay, they have given you the structure. Okay, now students, you already know that if there are sigma and pi bonds, okay, you can calculate Z, which is equal to number of sigma bonds. And if you can see if you can see lone pairs plus the number of lone pair of electrons. Okay, if Z value is 2, it is sp hybridization. If it is 3, it is sp2. It is 4, sp3, and so on. Okay, so this is one of the method to determine the hybridization. So in this is a big molecule and there are a lot of carbon atoms here. So if you see a if you see a single bond, reduce the thickness. So if you see a single bond, it is sigma. And if you see a double bond, one is a sigma and the other one is a pi bond. So we don't consider the pi bonds here. So now students, instead of numbering it here, let's redraw it and do it. I hope this part is clear. Yes. Now, let me increase the thickness. Okay. So I will write this at the side. So they want only sp and sp2. So if Z value is 2, it is sp. If Z value is 3, it is sp2. Z value is 4, it is sp3, but we don't need this. We don't need this, right? Now let me draw the molecule. Okay. Now, first one is, this is CH3. Okay, so whenever you, because here, this is a carbon, okay, with a double bond O. So this will be connected to another carbon atom. That carbon atom cannot stay alone. It has to be with the hydrogen if nothing is mentioned, right? So then I have a single bond. So all these mounts are carbon, okay? All these are carbon. So it is connected to another carbon. This carbon is doubly bonded to another carbon, okay? Then I have a single bond. So here, if nothing is there, that's carbon. The triple bond can only be for the carbon. So Yes, so 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Sixth carbon has a triple bond. So triple bond is connected to another carbon here. So this is incomplete. I have to fill in the hydrogens. Okay, so let me just draw the skeleton first. Okay, so here is another carbon. So 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. This is the ninth carbon, but it has a double bond. The ninth carbon is connected to the 10th carbon by a single bond. That 10th carbon is connected to nitrogen. Okay, so you have to be careful. If you miss one carbon atom, it will be wrong. So let me check the carbon atom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 carbon atoms. Okay, and 10th one is connected to nitrogen. Now here, for carbon 1, 2, 3, 4, the bond is satisfied. So for this, I'll fill in the hydrogens. 1, 2, 3. So fourth one. 1, 2, 3. Fourth one will be hydrogen. 1, 2. So this is not, valency is not satisfied. It will be 2 more hydrogen. Here 1, 2, 3, 4. So this is satisfied. 1, 2, 3, 4. This is satisfied. For this 1, 2, 3, 4. 1, 2, 3, fourth. 1, 2, 3, 4. So here it is satisfied. Now here, wherever there is single bond, that means there's a sigma bond. Double bond means one is a sigma bond, other one is a pi bond. We don't need the pi bond. This is sigma. This is sigma. The other one is a pi bond. We don't need it. This is sigma. Sigma. One sigma and 2 pi bonds. We don't need the pi bond. I'm not writing it. Here, sigma. And I missed out here. Carbon and hydrogen is connected by sigma bonds. So I cannot miss those. Okay, here sigma. Here sigma, 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 sigma and 2 pi bonds. Okay, so I don't need the pi bonds. I'm not writing the pi bonds. Now, we will use this information. If there are 2 sigma bonds, because there are no lone pair of electron, I'm ignoring this lone pair. So number of sigma bonds. If there are 3, that means this carbon is sp2 hybridized. There are 3 sigma bonds here, right? Again, I'm ignoring this because over here, if you see, carbon is bonded to 3 hydrogen atoms, right? And there are 4 sigma bonds. 4 means what? sp3. We don't need the sp3 hybridization, so I'm not writing it. So I'm starting with this carbon atom, sp2 hybridized. So first carbon atom, or let me make this first one. This is second one. I'll change the color better. This is the second one, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. Okay. So the first carbon atom we don't need because it is sp3 hybridization. They have not asked for that. Second carbon atom is sp2 because there are 3 Z values. There are 3 sigma bonds. Now the third carbon atom, 1, 2, 3. 3 sigma bonds corresponds to sp2. Fourth one, 1, 2, 3. 3 sigma bonds corresponds to sp2. I have written down the information here. Fifth carbon atom, 1, 2, 3. And 4. Fourth carbon atom corresponds to sp3. We don't need sp3. We don't need it. Okay, the question is sp2 and sp. Okay, sixth carbon atom, 2 sigma bonds corresponds to sp. Seventh one also, 2 sigma bonds correspond to sp. Eighth one, 3 sigma bonds corresponds to sp2. Next one, 3 sigma bonds corresponds to sp2. The last one, 2 sigma bonds corresponds to sp. Now, students, you have to tell me how many sp bonds, sp hybridization is there. 1, 2, and 3. So sp is 3, sp2 is 1, 2, 3, 4, 1, 2, 3, 4, oh, 5. 5. So I was missing out something. So 5. So sp3 and sp3, there are two, but the question did not ask for sp3. So sp and sp3. sp is 3 and sp2 is 5. So that is 2 is our answer. So always when this type of a question is there, you redraw it. Otherwise, you will miss these hydrogen bonds. Okay. I hope I'm clear. Okay. Coming to the next question.